Page 13 on the bottom where it says 3 cotangent x over 2 plus 1. 3 cotangent x over 2 plus 1. So you need to graph that. So cotangent again is cosine over sine. So you're going to start with sine x over 2. So go ahead and try that. Okay, first let's move our axis up 1. Okay, next we're going to graph sine x over 2. When we're graphing sine, we're really graphing sine. So that means the period is going to be 2 pi over b, not pi over b. I know it's very confusing, but we are just starting with sine, so you really do just graph sine. Okay, so the period is going to be 4 pi. So then from here, we're going to draw our sine graph. So 4 pi. So this is going to be half of the period, and this is also half. And half of that, that's 1/4. So it's going to go up to the amplitude, down to the amplitude, back up. So, sorry, I did this wrong. That's half of it. So this is up, down. So we actually only see half of it. Because it's 4 pi is the period and 2 pi is half of it. And then this goes down and then back. So like that. Okay, from here, we need to draw the asymptotes. The asymptote is where it crosses the 0 on the new axis. Halfway in between, starting point. Halfway between that, so this is where a lot of people start freehand drawing this. Not a good idea. Okay, halfway between that goes up to the amplitude. Halfway between that goes down to the amplitude. Amplitude is 3 up from the new axis, 3 down from the new axis. So this is going to look like that. A lot of you that I looked at, you just kind of did this. Usually it's okay, but then when we start analyzing this, it's not a good idea. So not good. Halfway, draw up to the amplitude, down to the amplitude, and then connect the dots. Any questions? So today we're going to analyze these graphs. So you got to draw them first and then analyze. Okay so far? Maybe? Okay. Okay, we are analyzing. Okay, so we can either do this by drawing the graph ourselves or we can use our calculator. I'm going to show you both. That way you have 2 tools that you can choose from. Let's just all take out our calculator so we know how to use it. First thing, your calculator must be in radian mode. If you're in degrees, you're going to see like a flat line and you would not know what that is. So make sure your calculator is in radian mode. To change the mode, you go to mode again, and then third line down it says radian or degrees. Whichever one has the black background is the mode you are currently in. So if you don't like that one, you just go to the one you want and then press enter, and it's going to change over. So everybody must be in radian mode. Good? Okay, next. When we graph this, your calculator does not have a secant function. So what should we do? Okay, we have to change it to a function that your calculator has. Your calculator has sine, cosine, and tangent. Yes, 1 over cosine. So you need to type in 1 over cosine 3x in order to see this graph. So you're now going to go to y equals where you usually graph, and then you're going to type in 1 divided by cosine 3x. And then just press trace and you should see the graph. So it's your normal secant graph. Okay, first part is already really hard, domain. Let's not do domain first. Let's do the range. The range is the easier one, I guess. What do you guys think the range is on that secant graph?
The range?
Yes.
1 to -1.
No. You would be describing the cosine graph if you were to say between -1 and 1. So look at this graph. Where does your graph actually exist? Someone raise your hand. I think the combination of all the answers is correct.
1, 2, 3. Oh,
Okay, yeah?
is it negative 1 to, or negative infinity to negative 1,
Okay, negative infinity to negative 1.
and then 1 to infinity.
Okay, good. Bracket or parentheses? Yes, bracket. We do have a solid dot on that point. So, yes, bracket. We must do the domain. Okay, so either you just kind of look at it and then you try to estimate where the asymptotes are, which, did you guys get this graph? No, you didn't get this graph. It's pretty hard to analyze from your calculator because you gotta kind of predict where it is. And your calculator is not gonna tell you pi over 2, pi over 3. It's gonna give you decimals because it's calculating from 3.14. So I don't think that's a great idea. So let's go ahead and just review graphing secant 3x. Ooh, 3x is gonna be a little hard. 3 is not a nice number to go into 2 pi. Okay, so the period is gonna be 2 pi over 3. Oof. Okay, this is not good. 2 pi over 3. And then this is up 1, down 1. Okay, break into half. 2 pi over 3 over 2. 2 pi over 3 divided by 2. There's 2 pi over 3. Cut it in half. Huh? Yes, pi over 3. Cut it in half again. Pi over 3 over 2. Yes, pi over 6. Add a pi over 6 to pi over 3. Oh my gosh. Okay. Pi over 6 plus pi over 3. 2 over 2. That is pi over 6 plus 2 pi over 6. Pi over 2. Okay, draw the graph. This is the cosine graph. So start on the top, down, down, up, up. Okay, draw the asymptotes. Let's just draw one more so it's easier to look at.
So,
Yes.
Can you do the graphing like on hand might be better than
I think so. Yeah. Finish drawing the graph. Okay, next, draw the secant. Okay, where is the domain? Everything but the asymptote, right?
yeah.
Okay. Where are the asymptotes?
Oh,
Pi over 2,
pi over 6,
pi over 6,
negative pi over 6,
and then
negative
negative pi over 2. Yes?
So is it like odd multiples of like pi over 6 or something
Yes, that's a great question. How are we supposed to write everything, right? Because we can't just say that's just those 4. It's everything forever.
Can we just write
Yes, so we're going to have to write some kind of equation.
or can we just say x can't equal to
Yes, x can't equal to what though?
all that 4.
Those 4 and then,
Oh, so you want the other ones too?
yes, like forever.
Oh, yikes.
Okay, so yikes, that is quite bad, right? Okay, so this is what you do. You pick one asymptote and you ask yourself, how often does my asymptote repeat? So we can see that it's going to be pi over 6, and then the next one is pi over 2. So How far is pi over 2 from pi over 6? Pi over 3? Yes, it is pi over 3. But I'm going to tell you a faster way. Okay, what is the period of my graph? 2 pi over 3. Within 2 pi over 3, how many times did I draw my asymptote? Yes, so like the two ends and then in the middle, right? So basically, I cut my period into 2. Yes? My whole length is 2 pi over 3. I cut it into half to create my asymptotes. So then that tells me every half of a period, the asymptote happens. Yeah? So then my asymptote will keep happening every pi over 3, which is half of my period. Are you guys with me? Okay, so I know that it's going to happen once I add another pi over 3, and then another pi over 3, and then another pi over 3. It's going to keep happening every pi over 3. How do I say every pi over 3? I just put an n. And then I say that n is all integers. So I'm saying when n is 0, it's just pi over 6. When n is 1, it's going to be pi over 6 plus pi over 3. When n is 2, I'm going to add 2 more over. N is an integer, that means I can be negative. So I can go negative 1, negative 2, and so on. Okay?
Do I have, when we do the test or something, we have to write n?
Yes, because you got to tell them what, you introduce a new variable, you have to tell them what your variable means. Okay, continuity. Oh, infinite. When you have vertical asymptotes, it's going to be infinite discontinuity. Jump is like your graph goes like that and jumps. Okay, so that's not a jump. Infinite discontinuity. Oh, okay. Increasing, decreasing. This is.
Do we say all of it again? No, wait.
We're going to have to say how often it repeats, but
Okay.
this is going to be crazy. Okay. All right, so what you do is it's repeating, right? There's a pattern. So you grab 2, that's the pattern before you repeat. So I'm going to just say here. You can pick any 2 that is the shape you want. From here, let's write a increasing, or all the increasing possible. From where to where is this increasing?
Pi over 3 to 2.
Increasing goes up. Okay, sorry. We're gonna look from here. So you see how I have one up, one down? That's my pattern, right? So I'm gonna repeat that pattern. So from this pattern, what is the, give me one increasing interval. What? No. Yes, 0 to pi over 6. Increasing. This part is increasing.
Oh, wait. Oh, sure. I was looking at
Increasing, goes up from left to right. Increasing. So 0 to pi over 6. Good. Do we include 0?
Yeah.
Yes, there's a point. Do we include pi over 6? No, there's an asymptote. Okay. All right. You guys will be fine. It's just being very diligent.
We're like pi over 6.
0 to pi over 6. All right. There's another part that's increasing.
It's pi over 6 because those are the x values now, right?
Yeah, we only look at the x values. When we talk about intervals of increasing, decreasing, it's only the x intervals. Okay, there's another place that's increasing.
From the negative. No, sorry, not that. I meant pi over 6 to
Pi over
Yes, pi over 6 to pi over 3. Okay, no, not include pi over 6. There's an asymptote to pi over 3. Okay. Let's leave it like that for now.
Okay, good.
For now, because, yes, question.
So any other question?
No.
Okay,
This
good.
is not on the question mark.
Good.
Only up to, I said 4? 4.4, yeah. Okay, decreasing.
From negative pi over 6 to
To 0, yes. Okay, negative pi over 6 to 0.
and then from pi over 3 to pi over 2.
Yes, and then pi over 3 to pi over 2. All right, here we go.
Oh,
I know.
Roller coaster.
How often does that part of the shape repeat itself? So let's just take one part. Let's take this part. Maybe you can't see that very well. Huh? Maybe this part, the left-hand part, the decreasing part. How often when is the next time we're gonna see that again? How much later? 2 pi over 3.
Oh.
Because that's the period for it to repeat itself. Does that make sense? This whole shape, this pattern, repeats itself 2 pi over 3, because that's the period, right? So then this shape is going to repeat itself 2 pi over 3 later.
Oh, so then we have
Yes? Are you guys okay?
that plus
Okay, so yes, so we got to add that in there. Okay. Okay, let's just make it really easy for you guys. Usually I write plus 2 pi over 3 and all that stuff, but let's just have you say repeat every 2 pi over 3 n. Okay, make it easy on everybody. 2 pi over 3 n. Symmetry. Odd, even, neither. Odd means turn 180, looks the same. Even means over the y-axis it looks the same. Neither means does not have a symmetry or not one of those. Huh? Even. Yes. Mirror image over y-axis.
and then odd is the one that is
Rotate 180, it looks the same. Huh?
Odd is also like intercepted over by x, right?
No, that's inverse function. Boundedness.
oh that's the wait no.
Unbounded. Yes, unbounded.
We finally got to this
Okay. Let's skip extrema. I know you guys will hate it. Let's do asymptote since we did the domain. The asymptote should be easy, right? It's the same thing except you have an equal to instead of not equal to. I already said n is an integer, so I won't write it again. Okay, here we go. Extrema. Oof. All right. First of all, you have a question?
Yeah, for the boundedness, why
Yes.
is it not like bounded like because in the middle?
When we talk about boundedness, we're talking about the highest y and the lowest y. In the middle, there is like a sort of a bound for the one curve, but it keeps going down. So, yeah. Okay, first of all, this graph, does it have a relative or absolute extrema? We said local, right? Before? Sorry. Local and relative mean the same. So, is it a local, relative, or absolute? Huh?
No, I think
Local, okay, is it local, extreme, or absolute?
is it absolute? 'Cause
How many people think it's local something? How many people think it's absolute something? Okay, it's local. Absolute means it is the absolute highest point. Well, we have a lot of dips and we have a lot of mountains, but they are not the highest point ever. It's just around there that is pretty high, but there's another point that's higher. So they're all local something.
I just really looked at cosigning it.
Yeah. Don't look at the cosine. Okay, local max. All right. Local min. Okay, x equals. So we just want to tell them where they are on the x-axis. Tell me where one local max is. Please look at the secant graph, not the cosine graph. Ooh, you're looking at the cosine graph. Look at the secant graph. Local max. Huh? 1? No. The x value, not the y value. Yes, pi over 3. So one local max is here, the one that looks like a hill. Right? So on the red graph, not the blue. So pi over 3. How often will it repeat? Huh? 2 pi over 3, the period again. Because that shape has to repeat itself one period over. Yes?
For the asymptotes, isn't it pi over 3n?
Oh, I'm sorry. Yes, you're right. I wrote the wrong thing. Yes. Sorry. You are correct. Yeah, it's the same, exact same thing as the domain. Local min. Yes, so you can see 1 is at 0, and then we say 0 plus 2 pi over 3, but that's irrelevant to have 0 in there since it's just 0. So we can just say it's every 2 pi over 3 n. Are you guys doing okay? This is pretty hard. Yes, definitely.
Like a hot second to process.
Yeah. All right, cotangent. Cotangent. So if you wanted to graph on your graphing calculator, which is not that helpful with your analysis, you can do 1 over tangent. But let's just graph it. So we're going to graph our cotangent graph. So that means we're going to start with sine. So this is why you can't freehand draw this, because if you draw it wrong, you're going to be analyzing the wrong thing. Okay, so this is the cotangent graph, which means it's a decreasing function. Okay. Okay, let's start with the easy one, range. All real numbers. You guys ready for domain? Okay.
Also, we have to
X is not equal to where all the asymptotes are. So where is one asymptote? Pi, yes?
2 pi.
Okay, pi, 2 pi.
Negative pi, negative 2 pi.
Yes, there's one at 0 as well,
Oh, yeah, 0.
right? So then how often do they happen? Pi, every pi. And then we're starting at 0, so then we can just say it's just not equal to pi n. Continuity. Yeah?
Do you have to write n equals infinity?
I'm sorry, yes. Continuity. Yeah, infinite. So anytime you have a vertical asymptote, it's going to be infinite discontinuity. Increasing. Nothing. None. Decreasing. Yes. From where to where? 0 to pi. Do I include 0?
No.
No. Do I include pi? No. Okay, so 0 to pi. Every pi. Symmetry. Odd. Okay, so if you're not sure if it's odd or even, what you can do is definitely not even, right? It has to look the same across the y-axis. You can also turn your iPad 180, and then if it looks exactly the same around the origin, the key is around the origin, then it's odd. Boundedness. Unbounded. Extrema. None. Yeah. It only will have an extrema if you go up and then down. Since it's only going in one direction, there cannot be an extrema. Asymptote. X equals pi n. Yes. Yes. Nice. Let's see what else we have to. Solving. Okay. This is solving with the knowledge of unit circle. Okay, so cosecant equals to 2. We only memorize our unit circle in sine cosine, so we gotta change it to sine and cosine. So cosecant is what? Okay, 1 over sine is 2. So sine is what? So remember I said if you want to find sine, 1/2. So flip this, right? Flip this side. Okay, all right. We got people who gave me confused look. Okay, cross multiply. Okay, 2 sine x equals 1, sine x equals 1/2. Okay, sine x equals 1/2. Now, no unit circle in your head. Sine of what angle? So think about sine. Sine is the y direction of what angle will give you. It's so funny. It's like we're on my unit circle. Which angle is gonna give me sine? Give sine a 1/2. 30. Oh, okay, in radian.
Pi over 6.
Pi over 6. Another one. 5 pi over 6. Because let's look at the requirement. Only 2. The other 2 are gonna be negative. Now look at the requirement. From pi over 2 to pi. From pi over 2 to pi means which quadrant? Second quadrant. Pi over 2 is in the middle. Pi is on the right. So second quadrant. So which one of those 2 angles that I found is from second quadrant? 5 pi over 6. So that's the only answer. So make sure, usually these questions will have 2 answers, and you have to find the one that meets the requirement. Okay, try another one. Ooh, cotangent. Not our favorite. Cotangent is what function over what function? Okay, cosine over sine. So this is a little bit tricky. Unless you memorize all your tangents, then this is very easy. If you don't memorize all your tangents, you only memorize sine and cosine, then it's a little tricky. All right, cosine of what angle over sine of what angle is going to give me, when I simplify, a square root 3. Okay, the key is square root 3, right? So what do I have to do so that I have only a square root 3? Remember, square root 3 will come with square root 3 over 2. Square root 3 over 2 will always come with 1/2. Yeah? They come together, right? So this will only happen when you have square root 3 over 2 over 1/2. Okay, this is the only way you can simplify and get a square root 3. The problem is, where is that angle?
7 pi over 6.
So this is when cosine is that number and sine is that number, or the negative version, right? Negative is also going to give me the same ratio. Huh? Cosine is longer than sine. Where?
100.
7 pi over 6? Yes.
And pi over 6, yeah.
And pi over 6. Are you guys okay? The people who are nodding their heads are good, but the people who are not, are you guys okay? Maybe. Pi over 6, 7 pi over 6. So kind of think about your unit circle. When is cosine longer than sine, but have the same sign? Here and here. Cosine longer than sine. Cosine longer than sine. Okay, let's look at our requirement. Negative pi to pi. Negative pi to pi. Okay, so definitely not this one, right? 7 pi over 6 is bigger than pi. So not gonna work. So pi over 6, but there's one more angle. The coterminal angle with 7 pi over 6. In the negative form, because you want the negative angle.
Negative 11 pi over 6, right, or pi 6. 330 degrees.
The same angle as 7 pi over 6, but negative direction. No. So 7 pi over 6 is right here. You want to go in the negative direction and get there.
Negative 5 pi over 6. Isn't it negative 5 pi over 6?
Yeah, negative 5 pi over 6. Okay, positive direction, 7 pi over 6. Negative direction is going to be negative 5 pi over 6.
This was fun.
Yeah, if you got your unit circle all memorized, it's funner. Maybe. Okay, last one, calculator. Let's see what time it is. Okay, calculator. Cotangent x is negative 0.6. Cotangent is not on the calculator, so what should we do? Break it down, but since we're using the calculator, we want to do it faster. Yeah, 1 over tangent is equal to negative 0.6. Okay, I'm going to use my trick. Tangent is equal to negative 1 over 0.6. Okay, so we want to find x, which is going to be our angle. To find x, we need to get rid of that tangent. To get rid of tangent, we use the inverse tangent. So if you kind of recall from very early on, the inverse function of the original function is going to cancel. X is inverse tangent, negative 1 over 0.6. Okay, so you got to use your calculator and figure out what that number is. Inverse tangent is found by pressing second and then the tangent button. Make sure your calculator is in radian. I think you have not changed it because the question says radian. Okay, what number did you guys get? Okay, negative 1.03. All right, let's look at our requirement. Between 3 pi over 2 to 2 pi. Which quadrant is that? Fourth. Okay, so you have to ask yourself, is negative 1.03 there? Yes, but we don't want negative, we want positive. So add 2 pi, so you can get back into the positive. I know. 5.25.